Alright, so section 4.7 is on something called writing quadratic equations in vertex form. We want to do two things. Number one, be able to write them in that form, learn how to do that. And secondly, understand how that relates to what's called transforming a graph. So that means moving it up and down, right and left, and so on. Okay, so we already know from past sections, we know that standard form for a quadratic equation looks like this. Vertex form, that's standard right there. SF means standard form. Vertex form, VF, looks like this. Y equals A. And by the way, that A is the same as the one in standard form. Times x minus h squared plus k. So I'll give you an example. Suppose you had this equation. Y equals 2 times x minus 3 squared plus 4. Okay, this is in vertex form. Why is that useful to us? Because it tells us where the vertex is. The vertex here is going to be whatever x value makes that parentheses 0. And obviously x equals 3 would make that 0. 3 minus 3 is 0. And then you have 0, the whole thing squared, times 2. That's still 0. Plus the 4 out there would be 4. That's the y-coordinate of the vertex. So it's very easy to locate the vertex when something's written in vertex form. It's not as easy if you had it written in that form right there. It also tells us where the graph is going to be transformed. So if you look at this picture, that's the parent function. That blue graph is what x squared looks like. Okay, this graph right here, the red one, if you may remember from an earlier section, there's kind of not an acronym, but a little saying that helps people remember. Add to x, the graph is going to go left, and then add to y, the graph will go high. So x minus 2, you're subtracting from x, you're not adding to x. So that means if you're subtracting from x, you're going to go right, and you can see in the graph I move to the right 2. And then this one is not adding to y, but subtracting from y. This minus 4 is going to move it down 4, so you can see that on the picture right there. That's why it's useful to have things in vertex form, because we can then apply that to a graph. So how do you write something in vertex form? You basically do it by completing the square. So let's do each of these right here. Completing the square, normally it's something that doesn't factor, so like that right there is not going to factor. Normally we would move it over to the other side, but in this case we'll just keep everything on the right side. The reason being is this is not equal to 0, it's equal to y, so we don't want to necessarily start. It's not wrong if you do it, but it's easier to just keep stuff on the same side. So let's move the minus 5 over here. We're not going to really use it anymore. And then we have x squared plus 6x, and then I'm leaving a big space so that we can complete the square. Okay, so we have this big space right here that we want to complete the square. And how do we complete the square? We take half of this number. Half of 6 is 3. And then we square it. So 3 squared is 9. So we're going to add 9 right here. Okay, normally if we add 9 to one side of the equation, we would add 9 over here. But again, I don't want to mess around with the left side, so I'm just going to balance it out on this side. So right here I added 9. Well, if we think about it, how could I balance out adding 9? How could I cancel that out? And the answer is I could subtract 9. Okay, hopefully that makes sense. If you add 9 right here, and then you take it away again, it's like you didn't do anything. You balance things out. So we have y equals, this thing right here will now factor. Okay, that is going to be x plus 3 squared. Where did 3 come from? It was half of this number. And then minus 5 minus 9, that's minus 14. This is now in vertex form. The vertex of this would be what x value makes that parentheses 0. And that would be negative 3. Negative 3 plus 3 is 0. And then this number here is the y, because 0 minus 14 is negative 14. So there is the vertex. Okay. This one's a little bit trickier. So again, we're going to move this number off to the side. Normally we would move it to the other side, but in this case we're just going to keep it out of the way. It's not really going to factor or anything like that. Okay, now what do? Well, completing the square only works when this number is 1, which it's not. So in order to make it 1, I'm just going to pull out the negative 2. I'm going to factor it out from that parentheses. So when we do that, what's left behind? Well, this divided by negative 2 is x squared. This divided by negative 2 is minus 4x. And you can verify if you were to distribute the negative 2, it would get you back up where you started right there. Okay, so now we're in a position to complete the square. So how do we complete the square? We take half of this number, which is negative 2. We square negative 2 to get 4. Now here's the tricky part. Because this number negative 2 is out in front, it looks like we just added 4. If you go back to this problem, when we added 9, what did we do to balance that out? We took 9 away again. But here's how you have to think about it. You didn't actually add 4 right there. You actually added 4 times that -2, because the -2 is like distributing into that parentheses, distributing to that 4. So what is 4 times -2? That's -8. And you can think about it this way, if you want to balance something out. If you subtracted 8, let's say subtracting represents stealing money, let's say. If you steal $8, how do you make that right? Well, the opposite of stealing $8 would be giving it back, would be adding $8. So all we're doing here is we just did something, we just subtracted 8. We're balancing that out right here by adding 8. Okay, now we're in a position to simplify this. We have -2. This thing right here will factor to x minus 2 squared. Where did the -2 come from? It was half of -4x, or half of -4. And then 8 minus 3 is 5. This is now in vertex form, and that tells us a couple things. It tells us, number one, this has a vertex at x equals 2, because that's what makes that parentheses 0, and y equals 5, because when this whole thing is 0, 0 plus 5 would be 5. So it tells us vertex at 2, 5. It also tells us, because this is negative, that the parabola will open downwards. Okay, negative numbers in front make it open down. Positive ones, like the first example we did, would open up. Okay, so it says, we have a graph right here, write that equation in standard form. Which is the equation shown right there? Well, first of all, they tell us the vertex right here. So remember, the vertex form looks like this. So let's think about it. If I took 3 and plugged it in here, what would I have to do to 3 to get 0? I'd have to subtract 3 from it. Because if you plug in 3 right here, 3 minus 3 is 0. And then this number for y, that plus 2, just goes right in front right there. So let's see which ones we can get rid of. Those are -2 plus 3, so those are the opposite of what they should be. So we're down to A and B. How do we decide? We decide using this other information they give us right here. So we don't know if it's supposed to be A equal to -1/4 or A equal to -4. So let's do this. Let's just plug in this point. That's my y value. Y is -2. A we still don't know, but we do know that x is -1, so I'm going to plug in -1 right there. And let's just solve this for A now. So we get -2 equals -1 minus 3 is -4, and -4 squared is 16. So that's the same thing as A times 16, or 16A. And we'll subtract 2 from both sides because we're trying to solve this for A. And we get -2 minus 4 is that, equals 16A. Divide both sides by 16. We get A equals -4 over 16, which reduces to -1/4. That's our A value, and that looks like the only one that works is option B right there. So that is our result. Alright, the last thing we want to talk about is transforming graphs, and there's kind of 3 or 4 basic things you can do. You can move it right and left. So add to x, go left, we said before. You can move it up or down. Okay, this is the number that's going to move it up or down, so let me write that. This number tells you up or down. If it's positive, you go up. If it's negative, you go down. This number here tells you right or left. Add to x, go left, and I'll talk about why in just a sec. And then this number tells you if it's going to be a vertical stretch or a vertical shrink, a vertical expansion or vertical compression. If it's greater than 1, if you multiply something by a number greater than 1, you're going to vertically expand it. Like times 2, that means you're doubling it, you're expanding it, you're making it bigger. Smaller than 1 means you shrink it. And then finally, if A is negative, so if we compare this graph versus this graph, the negative is going to do this. It's going to flip it over the x-axis. That's called reflecting it over the x-axis. Basically what we said before is that it tells you whether it opens up or down. Alright, so let's describe these transformations. So we want to know, how do we get from f of x to g of x? Here's f of x, here's g of x. So let's go, we usually always start from the inside out. So first of all, this one right here, we said add to x, go left. Okay, why is that true? Why, if you add to x, seems like adding to x should make us go right. So why is it going left? And here's why. You think about what value, remember the vertex occurs when that parentheses equals 0. What x value would make the parentheses 0? And the answer is -2. So if you're at a graph where x equals 0 and you suddenly move to -2, which direction did you just go? You just went to the left. Okay, so that plus 2, add to x, go left, that means we're going left 2. So this one is wrong, because that says right 2. This one is a possibility. So is this one. And so is this one. So at least we eliminated one thing. Okay, the 1/3 is the a value, and the negative doesn't matter. The negative tells us that it goes over the x-axis, which this one does right here, and this one does here. This one is wrong because it says y-axis, so we narrowed it down. So what does 1/3 do? 1/3 is going to vertically stretch or vertically expand. Sorry, the other way around. Vertically shrink or vertically compress is what I meant to say. Vertically compress by a factor of 3, taking a third. Why is that? Because when you take a third of something, you're making it smaller. If you have $30 and you take a third of it, now you only have $10. You just made it smaller. So vertically shrink or compress. Okay, if we look at B and C, the only one, actually they both say that. They both say compress vertically by a factor of 3. So then how do we decide? We decide based on this number, and that number tells us whether it goes up or down. Add to y, go high. We're not adding to y, we're subtracting from y. So we're going to go down, we're going to go low. So that is option C right there. Alright, this one, same thing. Add to x, go left. We're not adding to x, we're subtracting from x, so we're going to go right 2. Okay, this is a little bit tricky. This 3 is actually inside of that squared. So that 3 squared is going to give us, that's like this. That's like actually a 9 if we got rid of that inner parentheses, or the outer parentheses, I should say. So what does 9 do? 9 is going to vertically expand because it's bigger than 1. It's going to vertically expand by a factor of 9, but none of these options have anything expanding vertically. They all have horizontally. So here's what you need to understand. Vertically expanding, vertically making bigger, is the same thing as horizontally making smaller. And if you don't believe that, let's say you just had like a box and you were to kind of stretch that out. Okay, if you were to stretch it out, if you would vertically expand it, you would horizontally compress it, you would shrink it in. And the opposite is true too. If you had some tall box right here and you kind of mashed it down, what would happen horizontally? Horizontally it would kind of expand outwards. So if you vertically expand something, you horizontally shrink it. If you vertically shrink something, you horizontally expand it. So this number is vertically expanding, that means it's going to horizontally compress. So this is a possibility, because that's compressing. So is this, and so is this. We said that minus 2 means it goes right 2, so that one is out. This one we already got rid of because we're not expanding horizontally. So we're down to C and D. What does the minus do? The minus flips it over the x-axis, not the y-axis, so that's wrong. And then plus 3 means go up 3. So that is option D right there. Alright, last thing is how do you graph something in vertex form? And basically the first thing we want to do is obviously put it in vertex form. So remember, this minus 40 just kind of hangs over here. In order to complete the square here, we need that to be 1x squared, so we're going to pull out the 4 and divide each of these by 4. 4x squared divided by 4 is x squared. Minus 16x divided by 4 is minus 4x. How do we complete the square? We take half of this number, which is negative 2. We square negative 2 to get positive 4. And then here's the question, what did we actually just do? We didn't really add 4. We actually added 4 times that 4. So we actually added 16. To balance out, or to cancel out a plus 16, we need to take 16 away. We need to minus 16 right there. And then we're ready to put this in vertex form. So we have y equals 4 times this is x minus 2 squared, minus 2 because half of negative 4 is negative 2. Minus 16 minus 40 will be minus 56. So there is our equation. Our vertex is going to be at 2 because 2 makes that 0, comma negative 56 because there's negative 56. So there's our vertex. We know it's going to open up because there's no negative in front of the 4. Okay, and then to get the rest of the graph, really you just need a couple more points. The vertex goes in the middle, so 2, negative 56. And then we need a point above and a point below. A point below and a point above. So we just take 1 and plug it in for each of these. For each of these x's, actually there's only one x right there. Alright, and then when we plug in 1 for x right here, we're going to have this. We will have 4 times 1 minus 2 is negative 1 squared minus 56. This whole thing becomes negative 60. And when you plug in 3, that will also be negative 60. So how would you graph that? Well, obviously this graph is not so good because it only goes down to negative 10. So here's basically what it would look like. You'd have a point at 2, negative 60. So like way down here. I mean, that's not drawing the scale, but pretend that's negative 60. And then you'd have 1, sorry, that should be 2, negative 56. Because that's where the vertex is. 2, negative 56, and then you have points at 1, negative 60, and at 3, negative 60. And you would connect the dots, and that is your parabola. So that is how to change things into vertex form, how to use it to graph, and how to talk about the transformation, section 4.7.